everyone. So now we head to the last part of today's hands-on. And until now, we demonstrate how you can search and download data on Marine Environmental Watch website from of NAUPAP. And then we also demonstrate how you can do the composite. Usually, as we saw in the exercise of monthly composite, the data is usually missing, and due to clouds and other reasons. And sometimes we need to have a clear picture of the chlorophyll condition in our area. For example, you can see in Tuama Bay, usually we have a strong cloud influence. So by doing either monthly or either daily or monthly composite, we can get a nice image of chlorophyll for our study area. So here we just demonstrated how you can do this composite and how you can get the chlorophyll map like this one. So now we will close today with by a simple demonstration of how you can generate a simple animation. Sometimes, our website give you the opportunity to explore the image on the browser, so you can search which images are clear and which one have missing pixels, and you can download those easily. But sometimes this work can be tedious and quite tough. So alternatively, you can download the images and create animations. So these animations, you can see them, many of them quite easily, and you can pick up the images of interest. So, and also you can see the pattern. Animation is quite powerful because not only can let you pick specific image, but also you can see the patterns or temporal change of of the data. So here, our notebook, this one, if you go to, again, in the same materials, time series analysis, 2.3, you can get these animations from monthly images. Sorry, this should be from monthly image, or it can be from monthly image or can from daily image, from any kind of image. As long as you have images, you can get the animation. And here again, we'll be using Matplotlib. We import additional things to handle the animations. We also include HTML that will help us display the animations on the notebook. Here we import additional module, which is PIL. This we use to read, for example, PNG images to our notebook. So similar to other notebooks, we just run the import, and if everything is fine, you get no error. And we import local libraries. And here we need to define where we read the data. So because here it looks like we are using monthly images for our animation, one thing we can do is at first, we will be using PNG images. One thing we can do is go back to our data download notebook, and here, instead of NC, you can specify PNG. And we can, instead of 2021, we can use 2020 from January to December, and then 2020. So we can just select this. This has one full year. This year we still don't have. So then we run it, restart and run all. I only change the year, month, start and end month. Same year, I changed 2020, start month and end month to 1 to 12. Sorry, also I need to change here. Instead of day, I need to specify that I don't want day, I want monthly images. And then now changing composite to month, changing composite to month, year to 2020, month to first, and end same year, and end 12. And then instead of net CDF, I have PNG. Then after I do this, it will be downloading the images. So here I have PNG images downloading. And then I can come here and I can check the images are being downloaded. So it's updating here. I will get the images here. And maybe we'll wait a little bit. This should finish. Okay, so now we already download the 12 images. So we use the notebook for download that we used before to download NetCDF. We use it to download PNG file. So please remember, you change composite to month, year to 2020, month to 1. So because it's monthly composite, day is ignored, you don't need to worry about. And then end year is same 2020, and then end month is 12. And then here the extension is PNG. Everything else remains the same. And then kernel, restart all and run. And then it will download and save the images to our folder. So then after that, we go back to 3, which is about animation. So we already load these modules and append the local library. And then now we will specify that the data will be reading from the month, and we will output in a folder we call animation. So someone said had issue above mentioned problem, index error. How did you solve it? We haven't solved it yet. We will solve it and provide the solution later. Please hold a little bit. And here, again, we define the variable. This is chlorophyll. And the input, yeah, just like we did here, the input is inside the month. So we will specify here that is SGLI month, and we will output to animation. And then now we search PNG files, okay? So if we run this, then we have our images selected. And then here, this is just a helper function. This will just read the images using PIL, the function I just explained. This module will help us read the PNG images. So we'll read this, we'll define this, and then, and here, this is just a function also that will help us load all the images. Then here we create our animation. So we define the output name, we call it GIF, and then this is a list of image. We will use this function to upload all the images and append them. And then from this list of images, which we'll read using peel, we can then create the animation. So here, peel is also able to generate GIF animation. We select the first one, and then we say save all images. And then this is the list of images that we want to append to this initial one. And then we here you can tune the speed of how fast, how slow the image change between one another. And then the resolution of the image. If you run this, then the GIF will be generated and displayed. So done means it's finished. And then if you go to the folder, which is the output folder, animation, and then you open this one, then you have your animation here. So you can see on top, you have the month changing for different months. And then here you have the chlorophyll being updated. So this is quite simple and straightforward. Here, this initial demonstration is using peel. We can also use matplotlib, but for this one, it's quite complex. All I will recommend is just to follow. If you want to understand more in detail, you need to spend a little bit of more time. This is here we can read using netcdf. So to do that, you can, again, if you want to use the monthly images, you can just download 1 year of 1 year going back to download notebook and download the same month, 1 year monthly images, and use them to generate the same animation. So here we will get in this one. So now we are getting monthly images, and we will use those monthly images to generate, this time we use netcdf to generate our animation. Okay. I won't spend time explaining the details behind because they're not quite simple. So what you will do is try to see if you can replicate the exercise. And here, with this exercise, we can display, later we will see how we can display the generated video using matplotlib. So this is the whole structure of this animation creation. So all I need to do is check if I have all files downloaded. So this is still running. Okay, so the netcdf, the monthly netcdf files are downloaded. So now, here, because we have one monthly image, which is 2021, I would recommend to avoid any issues. I would recommend here to put only 2020 images, GS 2020 images, and then run. So this one will show the star, meaning that it is working. The star meaning it is working, and then once it finished, you will see a number here. This number will, means that the processing has been completed. And then we will get some animation. But this is quite slow compared to the other procedure. If you download the PNG, you will get the animation pretty quickly. But here, it will take some time. And once this is finished, we can convert that image into HTML video, which is easily embeddable inside this one. So this is the animation. It's been completed, but because here it's pretty slow, it takes so much time to update and or refresh. But using this one, we can easily play it and see the animation on the browser. So this is much easier to export and save in different format. So please try to repeat the exercise. First, download the PNG here. If you already did it, change it to month, day, 2020, 1st January, and then 2020, December. And then here, put PNG. Get the PNG, download all of them. After you are done, come here and import libraries, all these libraries, and then run this cell to specify where you input your PNG files and where you output the GIF you will generate, and define these two helper functions and run this cell. Once this is done, it will print here done, and then you can look inside the folder you defined here, your GIF file, your animation file. After you complete this, again, download the monthly NetCDF here, only change here to NetCDF, get the monthly images, and then you can try to run this second part. This second part uses Matplotlib, and it's a little bit more complex, but it can generate, and it takes longer to complete, to finish generating the video. But you can get the video that you can display quite easily in HTML, just like this one. Once this is completed, it will show here the animation with a play button where you can play, stop, and play. So please try it, and if you have any issue, let us know. If there is something you missed and didn't follow, just raise your hand and let us know. I see someone got error that list index is out of range. I believe this just means you have empty list, meaning that for this one, you need to check that you are specifying the correct path, that your images are not empty. So you can easily check this by just copy, click outside this cell, press A, it will generate an empty cell here, and then copy just to see whether you have images or not. This one. Type list like this. If I hit enter here, of course now it's busy. Okay. If I hit enter here, I should see this list of, most probably when in your case, you might have something like this, that only displays empty cell like this. So yeah, you have something that is showing just empty like this. So what you need is to have is to make sure that you have the list of images loaded. Yeah, so some people get deprecation warning. So this is just a deprecation warning. So don't worry about it's not an error. So everything should be fine. As long as it doesn't create error. Warning is just a warning. So here we have our HTML video. So here you have this pause and play. You can pause it and play it. And you can open it in full screen. Yeah, you have a nice, nicely generated animation. You can control the speed and the other things. So you can see also, we see that in summer around time of day, we see pretty high chlorophyll concentration in this area. So we can see this kind of temporal change pretty nicely. So yeah, try it, and if you have any problem, let us know. For today's hands-on session, we'll close it here. So we will stay a while you try. If you encounter any error or you have any question or anything, please don't hesitate to tell us. Yeah, so if anyone has a question, comment, please just unmute yourself and say something. Yes, someone is asking whether we can change the speed of animation. Yes, we can change the speed of animation. For example, because we use different, for the two animations, you are using different procedures. For example, in the first one, we use kill. So you can change this parameter to let you control the update rate of the image. Loop 0 means it will continue to play. It's indefinite play. It will just, once it reaches the end, it will continue again. Always, we have resources here. You can read more about the exercise you're doing. If you want to know more about how to do certain things, you can check the resources. And for the case of matplotlib, you have here interval. So you can change and update the different parameters. So they help you control how fast, how slow. Okay. Okay, I see someone got error with NetCDF, with reading NetCDF, like I suggested earlier. So for this animation exercise, please, because we created a file before, here on this cell, please, instead of just keeping like this, previously it was like this, because we created a file, a composite file from previous exercise. So to avoid mixing files, because they might not have the same size, or they might miss some information we need. In that file, we only saved the data. So all these files you will download from NAUPAP Marine Environmental Watch, they include time information, but in that file, we just saved the data. So it means you might get error. So to avoid that, simply specify the pattern of the file you want to search. In this case, we only want to use 2020 files. So I believe if you do this, the error will be gone. Yeah, so this is same, two people report the same error, and the same error is coming from the time issue. So this can be solved by specifying, by adding this here. We'll continue for additional 5 minutes, and yeah, if you have any comment, questions, please don't hesitate to ask them. Okay, I believe everyone is being successful in running the animation, and you should get a nice map like this one, or the one that was created from PNG. Either way, you should have animation like this one, whether you use PNG or you use NetCDF file. And as we close, tomorrow we will continue from morning, and we will be focusing on how we can extract. Of course, here we say extract annual marks. In the first day, we introduced the Global Eutrophication Watch. So we just give an example of some of the analysis we do for the eutrophication assessment. But this doesn't need to be, this example can be applied. I mean, using this example, you can do many other analysis. Here, we just give an example of how you can extract annual marks from monthly images. We already downloaded today the monthly images, which are 2020 in Toyama Bay. We will just use them, extract the monthly annual marks, and display the annual marks and time when this annual marks occurs. And we will also see how we can simply focus on a specific point for our time series and do a simple trend detection exercise. So this will be covered tomorrow. And today we just completed this exercise. We saw how to browse and download the data. And yeah, sometimes data comes with a lot of cloud masked pixels due to cloud. So we saw how we can composite to overcome that and have a relatively clear image for us to analyze. And we also see how we can do the composite. The composite can help us identify different patterns, also can help us pick specific image in the year and other many uses. So yeah, if no one has a question, we will close it here today and hope to see you tomorrow for our day 3. Yeah, thank you.